Okay, folks, lecture 3. Let's get into type 1 versus type 2 errors. So this is a common area in the class where a lot of the students struggle with it, and I'm hopeful we'll be able to clarify it for you here. So when we talk about type 1 versus type 2 error, we recognize that when we collect data from a sample of participants to a population of individuals, that there's always going to be some error, right? What we collect in the sample is not going to perfectly match what we see in the population. But in terms of our decision process with the null and the alternative hypotheses, we have this nice little matrix table that helps us to decide and really clarify what's going on. So let's say that in a type 1 error, we decide to reject the null. So we declare that there is a statistically significant difference between the groups or the conditions, when the null hypothesis in reality is actually true. So we made the wrong call here. Similarly, with type 2 error, let's say that we decide that no, there's no difference between the means, when in reality there is. And so type 1 error happens when we reject the null when we shouldn't, and type 2 error happens when we accept the null when we shouldn't. I'll give you a quick example. It's really the only example that I know in terms of really making sure that folks understand the difference between type 1 and type 2 error. It was told to me in graduate school by one of my professors. Effectively, the story goes like this. A family is expecting a child. And for all intents and purposes, we have a mother and we have a father, and they're going to the doctor to check in on the status of the mother, who is at this point 8 months pregnant. So the family goes to the doctor to check up, and the husband is not feeling very well. Okay. So effectively what happens is the doctor says, you know what, why don't we just, do a quick urine test on you, and we'll just make sure, we'll check you out to make sure you're taken care of. And the doctor comes in and says, sir, I am so flabbergasted. I have no idea what happened, but the results of our test, as far as we know, state that you are pregnant, right? So we have a biological male who takes a test, urine test, pregnancy test, and ultimately is ruled in as being pregnant. Clearly, that is the wrong decision, right? So you have someone who is biologically male, not capable of being pregnant, but takes a test, and the test results indicate that he is pregnant. Type 1 error. We rejected the null. We said he was pregnant, but he's not really pregnant, right? So that's type 1 error. For type 2 error, we perform the same test, but on the mother, who at this point is 8 months pregnant. The doctor comes in and says, ma'am, I'm sorry, you are not pregnant. So in this particular case, you have someone who we state is not pregnant, but she very clearly is pregnant. I hope that's helpful for type 1 versus type 2 error. So then the next thing we need to think about is the difference between sensitivity and specificity. So when we talk about sensitivity, we're talking about our ability to identify patients who actually have a condition, the correct decision. And with specificity, we're talking about our ability to identify people who do not have a condition. So effectively, when we give a test, we want to make sure that the test can separate those who are positive versus those who are negative, and who correctly identify the positives from the negatives. Sensitivity is about correctly identifying the positives. Specificity is about correctly identifying the negatives. And so when a test has high sensitivity, it has a very low false negative rate, right? So it correctly identifies people, and there's very few people here. So if you look on the slide, you can see that all of the white circles represent all of the possible tests, and there are only 3 blue circles, which are false negatives, right? And for the specificity, you can see here that we have 1, 2, 3, 4, 5, 6, 7, 8 tests out of the group that had false positives. And so the goal here, of course, is always to have a test with good sensitivity and good specificity, which tells us that the test itself is very good at separating the true positives from the true negatives. And so a test that has high sensitive means it's very sensitive and has low false negatives, which means it makes the right call. And a test that is very good with specificity has a very low false positive, incorrectly causing someone to be showing up as positive that's not really positive. So when we do tests, we want to have good sensitivity and good specificity, because that gives us confidence that the test that we're running is a good match in what we're assessing. So in the next video, we're going to go ahead and talk a little bit about statistical power and then wrap up lecture 3. We'll see you there.